So good morning everybody. It's from Jayshree. I am going to take this analog and digital ICs. Under this topic is digital to analog converter. Right? So let us see what do you mean by digital to analog converter in detail. Okay. Digital to analog converter converts one form of data into another form. Okay. That is what this signal represents. Real world process produces analog signals which carries information pertaining to process variables such as voltage, current, charge, temperature, and pressure. It is difficult to store and manipulate, compare, calculate, and retrieve such data with good accuracy using purely analog technology. But the computers can perform these operations quickly and efficiently using these digital techniques. Therefore, but the computers can perform these operations quickly and efficiently using these digital techniques. Therefore, it is necessary to convert the analog signal from various transducers into equivalent digital data, which in turn act as the input for digital systems. The computers also need to communicate with people and physical process through the use of analog signals, which necessitated the process of digital to analog conversions. So this is what the block diagram of digital to analog and analog to digital converter. So here anti-aliasing and digital filter. This anti-aliasing filter gives this is what the block diagram of digital to analog converter, anti-aliasing and sample and hold circuit, ADC and DSP and digital to analog converter, deleter and smoothing filter. So what is digital to analog converter? So first we need to give this digital signal to the anti-aliasing filter. So what do you mean by anti-aliasing? The high frequency component face the identity of low frequency component. That is what anti-aliasing. Okay. After that, the output is given to the sample and hold circuit. This sample and hold circuit will convert this anti-aliasing filter into equivalent samples of this analog signal. So after that, this equivalent samples, number of samples is given to this ADC, which converts analog to digital signal. After this DSP was this digital signal processing, which converts again digital to analog converter. At last, it will smoothen the filter, and finally we get the output as the analog or digital waveform depending on the applications. Okay. So next one is what? Resolution. So resolution of digital to analog converter is defined as the smallest change that can occur in an analog output as a result of change in the digital input. Resolution of digital to analog converter is defined as the smallest change that can occur in the analog output as a result of change in the digital input. The resolution is always equal to the weight of the LSB and is also known as the step size. Since it is the amount of voltage, output voltage, that is nothing but V0, that will change the digital input data goes from one step to the next. Next one is what? There are various types of digital to analog converter. Number one is what? Weighted resistor digital to converter. Number two, R2R ladder. Number three, inverted R2R ladder type. So weighted type DA digital to analog converter. In a 4-bit digital to analog converter, which accepts the bits from 00 to 1110. This is a minimum value and maximum value. There are 15 discrete levels of input above the 0 level. Hence, it is convenient to divide the output analog signal into 15 levels above 0. Next one, the LSB of the digital data causes the change in the analog output that is equal to the 1/5 of the full scale analog output voltage. Next, the weighted resistor network is designed in such a way that 1 in LSB 20th position results in VR at 1/15 at the output stage. A1 is the 21-bit position must cause the change in the analog output, and the voltage that is equal to 2/15 of VR. Similarly, 1 in 22 and 23 bits must causes the change of VR, 4/15 voltage and 8/15 voltage respectively. So weighted resistance DOR, it is important to note that sum of the weighted assigns various bit position of the 4-bit digital converters must be equal to 1. That is 1/15 plus 2/15 plus 4/15, 8/15 is equal to 15/15 VR. In general, the weight assigned to the LSB is 1 divided by 2n minus 1, where n is the number of bits in the digital inputs. The main disadvantages of binary weighted digital to analog converter is the requirement of wide range of resistor values. So thank you all.